The most popular number system used today is the decimal system, where the base is 10. However, for most of history, another number system was more commonly used, the sexagesimal system, which has the base of 60. It was the preferred number system in astronomy in particular. This system had been used by the Babylonians during the 15th century BC and later by the Greeks. Medieval Islamic mathematicians, although familiar with the decimal system, most often used the sexagesimal system, which they adapted and improved from the previous civilizations. In the sexagesimal system, one unit is 60 instead of 10. Thus, in this system, we need 60 digits, 0 through 59, while in the decimal system, we only need 10. An example of the use of the sexagesimal system in our everyday lives is the clock, where 1 hour is divided into 60 minutes and 1 minute is divided into 60 seconds. After inheriting the sexagesimal system from Babylonians and Greeks, Islamic scholars improved and clarified the system. Similarly to the decimal number system, after the contributions of Islamic scholars, the sexagesimal system essentially became the system we use today. The Babylonian system was used in Mesopotamia around the year 2000 BC. It was a positional system in which successive places of a numeral represent the successive power or positive integers of the base 60, so it treated whole numbers and fractions in a unified manner. The system only had 2 ciphers and no special mark for the unit's place, leading to confusion. Because position values are not explicitly specified, there was no way to distinguish between possible values represented by a given set of symbols in this system. For example, these 2 ciphers could represent either 1 1/3 or 80 or many other possible values. After the 2nd century BC, Greek astronomers sought to alleviate some of the confusion created by only having 2 ciphers by using the 27 letters of the Greek alphabet to represent numbers. Thus, while these 2 ciphers could have indicated 1/3 in the Babylonian system, Greeks simply used the letter K. The Babylonian and Greek systems were refined by Islamic mathematicians. Like the Greek system, Islamic mathematicians used 28 letters of the Arabic alphabet as ciphers. However, while both the Babylonians and the Greeks lacked a differentiation of place values, Islamic mathematicians easily divided up the units and named the positions both in the fractional and whole part. Positive powers went from degrees, first elevats, second elevats, and so on, while negative powers were called minutes, seconds, thirds, etc. Each unit was comprised of 60 of the previous unit. The base of a sexagesimal number is 60. Thus, a digit n in the unit's place, called degrees, is equal to the decimal number n times 60 to the power of 0. Decreasing from the units are the minutes, seconds, thirds, etc. The digit n in minutes place is equal to n divided by 60, and seconds is equal to n divided by 60 squared. Increasing from the units are the first elevats, second elevats, etc. First elevats is equal to n times 60 to the power of 1, while second elevats is equal to n times 60 to the power of 2. Thus, the conversion chart for decimal to sexagesimal looks something like this. Let's look at a sexagesimal number in more detail. Here we have the number 1 second elevat, 6 first elevats, 3 degrees, 15 minutes, and 9 seconds. Using the chart, we know that the value of this number is 1 times 60 squared plus 6 times 60 plus 3 times 60 to the power of 0 plus 15 divided by 60 plus 9 divided by 60 squared. In order to convert the sexagesimal number to decimal, we simply multiply all of the numbers with their bases and add them all together again. This would be 3,600 plus 360 plus 3 plus 0.25 plus 0.0025, all equaling to 3963.2525. The cipherization and increased organization of the ancient sexagesimal system by medieval Islamic mathematicians was a tremendously useful contribution that perfected the system.